Let's get started with the second panel. We heard about shale gas in the first one. The second panel is going to look more at the power sector, things like nuclear power, renewables, a smart grid, energy efficiency. We have the great fortune to have Professor David Spence here from the University of Texas at Austin serving as moderator. He is an expert in business and law and politics and policy and regulation of different facets of the energy sector, sort of well-regarded teacher on campus, very popular energy law classes among many things, and he'll be our moderator for this session. So David, I'll hand it off to you.
Okay, thanks very much, Michael. As Michael said, our topic is the power sector, which of course is a very broad topic. There's a lot of similarities and differences that are worth exploring, and I'm sure the panel will explore them between the United States and France. Like many of you, I was a little bit tickled to see the picture on the cover of the program. It says France and the USA, but it's a picture of France and a Texan's view of the USA. But there are actually quite a few similarities, I think, when we get to the electric power sector and interesting points of comparison. What we're doing here in Texas and more broadly in the United States and what's going on in France and more broadly in Europe. We heard about one of the major differences in the previous panel. We rely a lot on coal, and so the shale gas revolution has different environmental consequences here in the United States as gas-fired power plants displace coal-fired power. The environmental benefits of that are pretty tangible and obvious. In France, cheap shale gas would be competing with an entirely different baseload technology, and we're going to hear a lot about that technology here on this panel. Both places we're moving to competitive markets, so that there should be some interesting comparisons to make there. And of course, the panel title points us in a particular direction by mentioning certain technologies: nuclear, smart grid, renewables, and efficiency. So I expect we'll hear about all of these things. And what I thought I would do first is introduce our panelists very briefly. I'm not going to go through their entire long bios. You can see those in the program. But I'm going to talk a little bit about their positions, and then we would proceed down the panel just as the previous panel did, speaking in alphabetical order, so moving from my left to your right. So let me give you the brief introductions. Dr. Franck Carré is a scientific director of the Nuclear Energy Division at the French Commission for Atomic and Alternative Energies. Before that, he has managed a number of forward-looking research and technological development programs there. To his left is Cyril Pinel. Cyril was appointed nuclear counselor at the French Embassy in Washington, D.C. He's been a special advisor on nuclear affairs to the Foreign Ministry and has been director for international relations at the French Nuclear Safety Authority. Dr. Finis Southworth is Chief Technology Officer for AREVA, Incorporated, where he's responsible for intellectual property, management, research and development programs, university technical relationships, and corporate technical expertise. Jean-Baptiste Siproudhis is the Vice President of Electricité de France. He's in charge of the company's corporate and public affairs. He's also worked previously in the law division there, managing competition law issues, among other things. And Professor James Sweeney is the director of the Procurt Energy Efficiency Center at Stanford University. He's also a faculty member who focuses on economic policy and analysis. So I'm expecting, and I think you're probably also expecting, a lively discussion on electric power sector issues. I've asked the panelists, consistent with the format all day long, to keep their remarks within 10 minutes, after which I will ask a couple of questions to get the discussion started, but then we will open it up to the floor for questions from the audience. So we will start with Monsieur Carré.
Thank you very much. So the purpose of this brief address is really to give you a short insight into various steps of energy transition in France, and to put, let's say, some aspects of the energy policy in the US and in France into perspective. At the end of the 60s, in fact, 80% of the energy needs of France were imported from outside France. And then there was a time when, let's say, a decision was taken to really invest into, let's say, economically competitive nuclear power plants. A call for tender was issued, and then American technology was selected and in a first program that led to establish 6 of these units. In fact, this coincided with, in fact, the oil shock that occurred in '73, and this reinforced, in fact, the trend of diversifying the energy, let's say, the energy mix of France at that time, while an increased share of nuclear energy, and this was the beginning of a large, let's say, initiative to build a large fleet of generating facilities in France that today accounts 58 pressurized water reactors, and that generate 75% of our electricity. So, and then this is the current situation, and what happened, what in fact the energy self-sufficiency rate that was only 20%, let's say at the end of the 60s, in fact dropped to 50%. It stays about at this level today. And also the greenhouse gas emissions, CO2, really dropped dramatically to the level of 6 tons per capita per year, and stays at this level at the moment, even though the energy demand had grown, which makes France being one of the European countries emitting the least greenhouse gases. Well, only Sweden, I would say, is beating France because it mainly dwells on hydro and nuclear power. Now, the deployment of nuclear energy benefited from a strong political support from the beginning, at least until the end of the 90s, both from the government and also from the Congress, from the Parliament. And what evidences that is, in fact, the continuing support, not only in reactor building, but also in building fuel cycle facilities to really optimize the fuel cycle back end and to organize for creating a high-level radioactive waste repository. And 2 acts have been voted on this, and the latest one was promulgated in the 28th of June 2006, and it sets plans to establish a geological repository. Another thing that evidences that is that in parallel with the industrial deployment of light water reactors, there has been, at least until the end of the 90s, a continuous support for the development of fast neutron reactors with a closed fuel cycle, which is really the vision of the sustainable nuclear energy system, in the sense that these future nuclear energy systems with fast neutrons and closed fuel cycle are, let's say, have a physical capability to burn 80–90% of uranium, whereas light water reactors today only use 0.5% of the content. Then this, okay. So in fact, also consistently with that, our utility EDF made plans for, let's say, building some fast neutron reactors around the middle of the century, if ever the price of uranium was to rise so much so that this type of reactor would become more economical, and if a type of such future reactor would be commercially viable at that time. However, having reached this time of the end of the 90s, in fact, the impact of the nuclear accident in 3 Mile Island and Chernobyl, in fact, had led the public to question let's say, nuclear energy, and really this led to the perception of, let's say, a nuclear whole solution, and to strive to take some distance. And what originated from that was, in fact, a political decision to abandon the deployment of fast neutron reactors in 1998 with the closure of the prototype of reactor Siproudhis at that time. Just to illustrate, in fact, the support that we got from the Parliament on this occasion, so the act that I mentioned that is currently framing the creation of a geological repository has a clause that really mandates our national laboratory to work with industry, the nuclear industry, on a prototype of fast neutron reactors that would demonstrate advanced recycling modes in the 2020s to optimize the ultimate waste form. But this gives an opportunity, in fact, to revive research on fast neutron reactors and to make progress on the fuel cycle and on the reactor in terms of safety and in terms of commercial viability. And then this, let's say, bill, well, is an opportunity for us to come back into the play of the developing fast neutron reactors at the best possible level. Now, coming back to the questions of the public, that came around the end of the 90s, of course, this was echoed by a number of positions, I would say, in Europe. And especially there were neighboring countries like Germany, Italy, Belgium, or Switzerland that decided to phase out of nuclear. And what it impacted, the impact it had on the energy policy was, first of all, to change the decision-making process in really making it necessary to have public debates for any piece of large infrastructure that be built. And this would apply to nuclear reactors first. Then also, the Energy Policy Act that was promulgated in 2005, in fact, had to take some distance from nuclear, and then it really emphasized the need for, let's say, controlling the energy demand and also of diversifying the energy sources, as well as having seeds of goals for reducing greenhouse gas effects, as well as for promoting, let's say, renewable energies. But at the same time, it was keeping the nuclear option open. And this was really refined by more recent, let's say, debates that were enacted, that led to decisions that were enacted in 2009 and 2010 that were more precise about goals for renewable energies and capping greenhouse gas emissions. So similar paths, in fact, had originated, well, in fact, these trends had been originated from Europe, and in fact, had, of course, impacted the energy policy in France, leading to these acts. And in Europe, in fact, major steps were a green book in 2006, setting goals towards a low energy future. And really, the European policy reached a peak while really working on the European Strategic Energy Technology Plan. And that really set strong goals like for 2020, like decreasing by 20% the energy demand, like cutting by 20% greenhouse gas emissions, like, let's say, aiming for 20% of power generation from renewables. And at the same time, the European Commission was screening the strategic technologies to achieve these goals, and it was promoting renewables. Especially, it acknowledged the significance of a fission of nuclear energy to really meet these goals. And this made it possible to become organized to work in Europe towards a common nuclear future, which was politically incorrect until 2007 because of the mixed feelings of the nuclear countries on nuclear. And the only cooperative work at that time was to optimize the operation of existing nuclear power plants. So currently, in 2012 and 2013, we just entered 2-3 weeks ago into a public debate on, let's say, on energy transition in France. And, well, there are different visions of what the transition means. Well, basically, I think it means transition from fossil energies and progressing towards low-carbon energy future. But depending on what are your sentiments about energy sources, some people think of transitioning from nuclear energy, some people think of transitioning from fossil and nuclear, and they think that renewable can do the job itself. So we just enter into a debate that is likely to come to, let's say, a new energy act that will be promulgated in the second semester of 2013. And good questions are, let's say, how to decarbonize, let's say, energy in France. Certainly energy conservation is one direction. Well, electrification might be another one, as our electricity is 90% carbon-free. Other directions might be diversifying energy carriers. And good questions are how much of renewables will we have, knowing that, in fact, the goal has been set up by our president to aim at 50% of nuclear electricity by 2025. And how the intermittency of these renewable energies will be managed, what investment this would call for regarding storage, smart grids, backup power. Will we have gas as backup power, and what will be the impact on the cost of the energy and also the emissions of CO2. So I'd like just briefly to conclude on commenting maybe some of this, let's say, graph that puts into perspective the situation in the US and France. Well, it is obvious that, in fact, the US are an energy-rich country, whereas France is an energy-poor country. So we spoke this morning of, let's say, the reserves of the US in coal, oil, gas, even uranium, I would say. There is no regulation on CO2 in the US. However, it was mentioned this morning already that, in fact, the Clean Energy Act lead gas to displace to displace coal, and there was a result in reducing the, let's say, CO2 emissions in the US, even though there is no goal. For what regards oil, in fact, we are both concerned, I would say, by reducing the expenses of importing oil, and this triggers, in fact, research on a way to to develop synthetic hydrocarbon fuels to add up to, let's say, liquid fuels of fossil origins. So the situation is nothing like, let's say, the gas. This is very different, and the price of gas in Europe, well, will really keep it for applications that really make it necessary. It's not displacing anything at this point, at least until shale gas is being exploited, let's say, in some countries. So some countries like the UK and Germany authorize prospection for it. We have a moratorium in France, and in France, gas will only, well, I mean, except for industry, for electricity, will be used for peak energy demand or for compensating for the intermittency of renewable energies. One last word on the vision of nuclear energy. Well, the vision of the future of nuclear energy in France is fast neutron reactors with closed fuel cycle, because this is the vision of the sustainability of nuclear energy that is so important, I would say, to the balance of our energy policy. Whereas in the US, there are new builds that are replacing some of the plants, but the situation of gas, I would say, that displaces coal is not really urging, I think, for a large, let's say, program of new builds in the US. And the vision for the future is of interest in the fact that the prototype that the DOE has assigned as a goal in the Energy Policy Act of 2005 is more high-temperature reactor for its capability to enlarge nuclear applications and to have, let's say, a low-carbon advanced energy process to synthesize synthetic fuel, whereas ours is a fast neutron reactors. And this illustrates the vision. I'm stopping here to not abuse too much of your time, but I'd be pleased to address some of these issues and others whenever you feel interested in. Thank you.
Thank you, David. Good morning to everyone. I want to thank also Michael and his team for organizing this seminar and putting me on it, and also my colleagues from the consulate in Houston. I'm very glad to be in Texas today. I must say that it is my first visit to Texas, so it's a pleasure to be with you today. My intention is to try to say a few words about the situation in France and the situation in the US, trying to compare in the field of nuclear energy, of course, trying to compare the maybe where we stand today and what are going to be the challenges both our countries are going to face in the near future. I would start with the situation in France. As my colleague Franck Carré said before, we have in France 58 nuclear reactors operating. That is actually the second fleet in the world after the US fleet with 104. So it makes us, France and the US, the two most important fleets in the world, and I think it gives us some special responsibilities. As Franck has also started to touch upon, the situation in France is today probably going to evolve in the field of nuclear energy. Our new government and our president has decided to try to go for a more, I would say, balanced mix of in the field of energy. It would give us some benefits in terms of independence and in terms of security, because as was said, we have around 75% of electricity coming from nuclear energy. This is very important, and the goal today, as our president decided, is to rebalance this mix and trying to go from 75 to 50% by 2025. Another decision which has been already taken by the president and the government today is that we should close one NPP, which is Fessenheim, because it is it is the oldest operating plant in France. So this plant will be closed by 2016 at the latest. Other decision taken is that we will continue with the construction of a new reactor in France, in Flamanville, the new EPR reactor, which is a third-generation reactor. So this is going to go on. We will also continue with the recycling of fuel. This is one difference between France and the US. In the US, you do not recycle fuel. In France, we do recycle fuel at La Hague. We will also continue with our MOX policy. We do make and use MOX fuel in plants. So altogether, I would say that this decision is an evolution of the situation, but certainly not a phase out, as our council said today earlier. It's not a decision to phase out nuclear energy. It's a decision to rebalance our mix. And it's nothing to compare with the situation in Germany, for instance, where it is decided to phase out nuclear energy. And on this thing, I just want to end with mentioning what the President has said in a very important meeting late September. He clearly reaffirmed the confidence of France in nuclear energy and in the French technology, and he wants to keep on with nuclear energy in the future, and for France, for national use, but also for exports. So we will still be active on the export market for nuclear energy with some countries interested. Of course, also he reaffirmed our commitment to the highest levels of nuclear safety for the operating fleet and the fleet to come. So I would say that the big challenge we have to face today, knowing this decision to rebalance our mix, is how are we going to manage this rebalancing of the mix, 75 to 50% of electricity coming from nuclear energy by 2025. It's really a huge challenge. And in my mind, there is something we should be very cautious not to lose. It is the competitiveness that nuclear energy has given to us in the past. Today, nuclear energy in France is one of the cheapest in Europe. To give you just one figure, companies in France pay 8 euro cents per kilowatt hour, and companies in Germany pay almost 13 euro cents per kilowatt hour. So this is a huge advantage we have with nuclear energy, and our commitment should be not to lose this advantage while rebalancing the mix. So that's definitely the big challenge we face. Of course, it will depend very much on the overall economical situation we're going to have in Europe and in France. Going from 75 to 50%, a way to reach that goal, if the economy is doing better, is to have more electricity demand, of course. If we have more electricity demand, we can rebalance the mix without reducing the fleet, and with having more renewable energy, of course. So this is going to be discussed in the coming months among experts in France, and we are going to have a new bill on this energy transition by mid-2013, so approximately in 6 months. So what's a few words about the situation in the US, where I also think there are very interesting things going on and big challenges ahead. First thing is a very good news. In the US, after more than 30 years, there are new builds. So there are 2 AP1000 being built in Georgia and 2 other being built in South Carolina. So this is really a very important news, and it's a very promising situation. Now, there is, from my point of view, after a bit more than 1 year in the US, in DC, at the embassy, what I see is that everyone in the US, but also in the world, in the financial community, is looking at what is going on in Georgia and South Carolina. So the big challenge today is that those projects go ahead within schedule and within the cost. That's certainly the big challenge and the big difficulty. We all know, because we've been facing the situation in France also with our new reactor being built. We all know that when you have not built NPPs for some times, it's more difficult to do it in time and within cost. So we hope the best for those new plants being built in Georgia and South Carolina, because once again, I think the whole world and financial community is looking at this and trying to make a decision for future build. Another challenge I see in the US is the back-end situation. You know the situation in Yucca Mountain. This project has been put on hold by the administration, and the new Congress today will probably face the situation and try to find a long-term solution for waste in the US. So in the coming months, I think that this nuclear waste will be a big issue with the new administration and within Congress. But I'm optimistic because I've seen very good signs that a number of congressmen are very willing to work together and find a solution for this issue, which is also a big challenge for the future of nuclear energy in the US. Maybe just one point to conclude. Between France and the US, it's a long history of cooperation in the nuclear field. I don't know if all of you remember, but actually the fleet we have operating today in France is originally Westinghouse. It's been customized, of course, but originally it was Westinghouse. So the history of nuclear energy in France and the US is a very close history. It's always been the case, and I'm confident that it will be the case again in the future. We have a number of cooperation agreements in place between DOE and CEA, between the agency in charge of waste management in France and DOE. So those agreements are, I think, very good tools to have high-level political discussion, policy discussions between the different people in charge, and also to have field cooperation, technical cooperation between the different actors in the field of nuclear energy. Personally, I see maybe two projects of interest for both countries. One is what we call the SMR, the small modular reactors. You know that it's more and more discussed that the future of nuclear energy may be also with small reactors. So the US is very interested in small reactors, and I think France is more and more interested in it also. And also, the second big project we might have together, as mentioned also by Franck Carré, is the fourth generation. I think there is work to do in the field of fourth generation reactors, and there are very interesting discussions going on between the two countries in this field. So, last word, I'm deeply convinced that nuclear energy has a future because as we can see in France and as we can see in the US, it is a very big advantage in terms of economy and competitiveness, and also nuclear energy is going on with, I would say, jobs, long-term jobs, and highly qualified jobs. So I think nuclear energy has a future in the medium and long term, even if today, because of the price of gas, the situation is what it is. And I think that France and the US should stay ahead of building this future for nuclear energy. Thank you very much for your attention.
Finis, I think you next.
Go next. Good morning. I'm Finis Southworth, Chief Technology Officer from AREVA, Inc., which is the North American part of AREVA. There's three major components to AREVA. One is AREVA France, which is the parent of the other two also, and the other two are AREVA GmbH in Germany, headquartered in Erlangen, and AREVA Inc. in the U.S., which is headquartered out of Lynchburg, Virginia, actually. A little bit about AREVA. AREVA is the largest nuclear vendor in the world, by far, about twice the size of Toshiba Westinghouse and triple the size of GE Hitachi and other vendors. As such, we provide an integrated capability all the way from mining. We mine maybe 20% or so of the world's uranium and supply it through conversion of that to uranium hexafluoride and enriching and making the fuel to go into the reactors. And we supply fuel to 140 reactors of the 440 that are in the world, so about 1/3 of them all. Of the 440 operating reactors, about little over 100, about 102, I believe, have a legacy of AREVA manufacturing as the NSSS provider or the progenitors of AREVA. In the U.S., actually, the progenitor to AREVA in the U.S. was B&W. B&W Commercial was bought by Framatome, which became AREVA, in about 1988. So just to give you some background on how AREVA came to be in the U.S. I just want to talk a little bit about how we got to where we are in the U.S. We do have, as Frank and Cyril mentioned, we have more nuclear plants than anybody else in the world. We have 104 operating plants with about twice the capacity of any other countries of France, approximately twice the capacity of France, which has 58 operating plants. But we're a much bigger country. France is 80% of electricity, roughly, in nuclear, and 50% of their energy economy is electricity, since they're heavily electrified. That gives them 40% of their energy in total comes from nuclear. We're 40% electrified, and the other 60% being in process heat and transportation and such, so that with our 20% of electricity that is nuclear, then that means we're about 8% of the energy economy. We have never been in the U.S. a significant impact on the overall supply of energy, but we have had the following effect, I believe, and I have been in utilities, or certainly I worked in Florida Power and Light for a long time, and saw this, that we went from 55% of our electricity coming from oil, believe it or not. We were one of the biggest users of oil. Some people blame Florida Power and Light for the 1981 oil shock, in fact, because we hijacked some ships off the open seas to fill an emergent need that we went ahead and paid an incredible price. And those tankers were diverted, and it cascaded into oil reached briefly, I think, $52 a barrel in 1981 during that summer. And if you recall, that would be, I think, equivalent to around $200 a barrel today. So it was the highest oil had ever reached, and it was a significant impact. Add that to the inflation and the recession of 1981. The net effect was that actually electricity use dropped that year by about 20% in the next 12 months. And that solved the energy shortage, frankly, because people had such a high price they stopped using it. And it didn't recover to the 1981 levels until about 1987. But what nuclear did as it got built out is it stabilized the energy markets. Natural gas has always been volatile historically. Oil has been volatile as a power plant supply. And so by having a base load or an increment of base load that was nuclear, it tended to stabilize that. It gave you the ability to use your intermediate load and plan your loads around some fuel diversity of natural gas and oil or coal or whatever. So I think the market, and this is just my speculation, basically built enough nuclear until it stabilized the volatile electric pricing. And since the mid-'80s, electric pricing has been much more stable throughout the U.S. than it was prior to that time. So I just offer that as my theory of how we got to where we are. The history of nuclear, and I'm just going to cover a little bit about the 66-year history, if you will, of nuclear power in the U.S. I'll cover that in about 3 minutes. And over those 66 years, the three sort of major social contracts have grown around three topics: nonproliferation, safety, and waste as the key issues. And oddly, they're still the three key issues because every time we believe we got them behind us, we're wrong. But let's look at the policy framework and the legacy, if you will. The Atomic Energy Act of 1946 established the Atomic Energy Commission. as part of that act, it said that weapons and nuclear power would be under the regulation of civilians, i.e. the agency. And it decided the military would have no role in regulating and controlling either. Military could use them, of course, but it would be civilians that would decide how and when and what form they would take. In 1954, the additional Atomic Energy Act enabled commercial ownership of nuclear technology in order to commercialize it for benefit, for making electricity and such. And this followed closely on the heels of the 1953 UN speech by President Eisenhower, who said that we will launch an initiative to turn swords into plowshares and use atomic energy for the benefit of mankind and its energy, and that we would share that with the world. So that was the reason that the Atomic Energy Act of 1954 made this significant change. There was what I regard as one of the most important changes at that time was that the Joint Committee on Atomic Energy in the Congress was established. A single entity, if you will, a committee that was both House and Senate that would set policy and funding and other things for nuclear energy development. That entity existed from 1954 to 1977 at the Energy Act of 1977 basically did away with that. So with that, any coherence in nuclear energy policy essentially disappeared, in my opinion. In fact, we've never had a coherent approach since. But nonetheless, in 1974, the Energy Reorganization Act was promulgated, which split the AEC into the NRC and ERDA, and in order to separate promotion of nuclear energy and nuclear weapons control away from the regulation of safety of nuclear power. So NRC and ERDA were split. We still had a strange mix of nuclear energy promotion and weapons in ERDA, which persisted even after it became a cabinet level in the 1977 Energy Act, where President Carter wanted to elevate ERDA to a cabinet level, and the Department of Energy was born in 1977. Nuclear energy has never been a priority since in the government. Under DOE, it's always been probably about the smallest of the 7 program offices, if you will. Science has always been about 10 times as much, and others. But it was interesting. And renewables typically is larger than nuclear energy, in fact, in DOE. So nothing wrong with that. I like renewables. We also have renewables in AREVA, by the way, both wind and solar. But another thing that happened with that act in 1977, which was significant, was that commercial reprocessing was stopped out of concern for proliferation. And so the efforts of Allied General, who had about $1 billion into the Barnwell plant, the West Valley plant by Westinghouse, the Morris plant by General Electric, overnight became abandoned assets, stranded assets. Similarly, it outlawed commercial enrichment. So the efforts of United Nuclear and Exxon Nuclear in Oak Ridge and in Richland became stranded overnight. Later on in 1981, President Reagan overturned that because it was just a presidential decision directive. It was an executive order. It wasn't really a law. But Reagan turned that over in about 4 years later, but it didn't make any difference. Nobody had the temerity to invest again with the risk that it could go away again. So it took a long time before anybody started down that road of, say, commercial enrichment, which they do now. We have several efforts going on in the U.S. for private enrichment. The next big change was the Nuclear Waste Policy Act of 1982, which sort of was on the heels or necessitated because of the changes in 1977. It was expected that we would reprocess, so we would use mixed oxide fuel, and we dispose of high-level waste in glass logs in some salt repository somewhere. That all became obviated, and we ended up with saying we needed direct disposal of used nuclear fuel in the form of fuel assemblies. And so Nuclear Waste Policy Act said, well, we don't know the answer to that, but it's up to the government to do it. We'll have the government take ownership of the fuel, and everybody will pay $1 million/kWh for them to take it away. And they'll take it all away by 1998. So that solved the waste crisis for all time, as you know. So in 1994, for whatever reason, we ended up with a very anti-nuclear energy secretary, Secretary O'Leary, who stopped essentially most reactors in the Department of Energy, all but the advanced test reactor, stopped reprocessing of all types. We hadn't produced weapons material purposely for quite a while, since 1989 when those facilities were shut down. But we were still reprocessing naval nuclear cores to refuel naval submarines. She said that shouldn't be necessary, and she stopped that. So that was terminated, and EBR-2 was terminated, and the integral fast reactor work was terminated. So most things that were ongoing were done away with that time in terms of nuclear technology development. And lastly, in 1998, U.S. met its nadir in the DOE progress in nuclear energy when zero funding existed for the year of 1998 in DOE for nuclear energy. Well, time's up. I didn't prepare any slides, so I didn't have much to say. So anyway, it's been an uphill climb for DOE since then, and in 1998, when Bill Magwood was made the Assistant Secretary for Nuclear Energy, he started two initiatives with the support of Congress. One was the Nuclear Policy 2010 Roadmap to foster Gen 3 reactors, the next generation of more safer, more economic LWRs, and the Gen 4 Roadmap to look what's beyond these large LWRs. Those were codified in the 2005 Energy Policy Act passed by Congress in August 8th of 2005. So with that background, I'll leave it there, given that we're running short of time, and thank you very much.
Good morning, everyone. I would like to thank the organizer for giving us the opportunity to cross our experiences and share our different views on the energy sector. My company, well, the company I belong to, EDF, is not well known in the US. It's a French first producer. It's well known in Europe, but just to give you, in a nutshell, a few facts. It's the first electricity producer in the world, with a turnover of about $85 billion with 170,000 employees. The idea is not to throw many facts and superlatives, just to give you an idea of what we do. And 87% of our production is carbon-free, not only thanks to nuclear, but also hydro, because we manage 240 dams in Europe. In the States, we have only 4,000 employees, but we are dedicated to three main areas. On the East Coast, we have a JV with Exelon on nuclear in Baltimore. And then in Houston, we've got energy services and trading in Austin as well. And in San Diego, we've got 800 folks dealing with green energies. Actually, EDF today deals a lot with green energies and innovation. It's not a marketing strategy. It's deeply rooted in our strategy, and thanks also to European regulations. I know Franck Carré pointed out that European regulation has a serious impact on the French policy, well, all member states' policy. But I think it's very important to step back and check what is our experience as a European Union member, especially with respect to the energy strategy. Maybe you've been aware of the Triple 20. By 2020, that's the European Parliament that has voted this regulation in 2007. By 2020, all member states will have to reduce the carbon emissions by 20%, and to make sure that 20% of the energy comes from green energies and reduce by 20% the imports. As a matter of fact, this regulation has a major impact in France on a very positive way, because it forces our company, but also states, region, to create incentives to enhance energy efficiencies. And incentives leads to a wide array of initiatives and boost innovation as to insulation the houses, but also educate people on how they could use energy and make energy savings. We talk a lot about industries, about policy. We don't talk about customers. And we feel that it is of the essence to educate customers on how they will make the new consumption for the future. In practical terms, it has forced EDF to work on smart meters, to work on new certificates, and on the decentralized productions. It means that we try to work on a way to improve the way people can be their own producer and produce their own energy, and beyond this energy, to feed the network with energy resources like renewables or other sources like thermal pump or all these kind of things. And in addition to that, it has forced us, well, forced is probably not the good word, but it has allowed us to work on smart cities, to bring energy efficiencies in a bigger shape, and to provide the public client with information and communication technology, ICT, in order to allow them to make more simulation on the way to spend their energy and to make the best decision to optimize the way they consume energy. And we start with Singapore and also in France, but we are starting also in the US to reach out to a big public client and to try to help them to work on a bigger scale and also on a long-term basis for a more sustainable policy. So it's probably the two things. And we work a lot in the West Coast. We spend $2 million every day in innovation, like for the MIT on the East Coast, but also for the EPRI and for basically many universities. We try to work on capital ventures as well. And all these popping up companies with brilliant ideas. And I'm sure that Jim later on will go back to this issue with some example like O-Power or brilliant people. My concern, and it's also EDF concern, is that considering the economic situation in Europe, it may have as a consequences to freeze the environment policy and to put this issue and initiative back in the calendar. So we definitely need in France and in Europe to have other major actors like the United States. It has the most energetic and dynamic market in the world to keep the ball rolling on these issues. And we're so happy to have Barack Obama elected in that perspective. I mean, for green energies, the big question mark is that will he keep his promises? And our feeling at EDF Inc. is that it's our duty, not only as industrial, but also for student, teacher, and political people, congressmen, to keep this issue on the top of the president's pile and to make sure that today it will move to new direction on a long-term basis. Thank you.
Great. I'm quite pleased to be here and actually to see a group of people who I hadn't expected to see before that I just had known in California. Well, I'd like to focus on something that France and US have in common. We both use electricity. France generates it mostly as nuclear, and we've heard a lot about nuclear so far, but I want to talk about the use of it and energy efficiency. But I want to start with what I think that we're really all about. At least I think that those of us who are in energy policy are about is really how do we move towards a long-term sustainable energy system. And I don't think it takes much looking to understand we're not there yet as a world or as the United States. Well, to be sustainable, there's a number of things that we have to think about: the economy, issues of the environment, and issues of security. And I'd like to just focus on those three elements as absolutely essential, I think, for a long-term energy policy as we get to a sustainable energy system. That's what I generally call the energy policy triangle, and I will just summarize that and relate it to energy efficiency. What I think about energy efficiency is the economically efficient reductions in energy use. That is, the reductions in energy use that are worth doing because of the trade-offs with security and the environment. So if we think about energy efficiency, using less energy is generally good for the environment, and certainly in the United States for global climate change. Anybody watching what's going on in the Middle East have to relate that there's something to do with energy and security, but we have blackouts and we have other more local security issues. And if we can get reduced energy use, that are doing it so it's economically attractive, we have economic benefits. So the probably efficient use of energy is the one way you can focus that gives you all three goals without, if you do it right, without necessarily having trade-offs. Now, in doing that, there's been a lot of studies that will tell you there's a lot of low-hanging fruit in energy efficiency. There's a lot of things that people can do, reduce energy, that for which the benefits exceed the cost for each individual, but they're not doing, low-hanging fruit. Now, as an economist, you know, I sort of scratch my head a little bit and think of if I had a big fruit orchard out there and there was a lot of low-hanging fruit and a lot of people around, but for 20 years nobody picked the fruit, you think that there was something in there. Maybe there's an electric fence between you and the low-hanging fruit. And I think, so that's what we have to go to, the energy efficiency. If you go to Ernie Moniz's chart at the beginning where he talked about what you need in the longer-term future, there was a cross-hatched area and it was called reduced energy use. And that's a fundamental thing that we may talk about, energy efficiency. So how do you get that is an issue? Well, as opposed to a lot of the supply-side technologies, this really has a lot to do with human decision-making. Supply-side technologies, of course, have humans making the decisions, but you can expect that the companies are doing a lot of optimizing in their choices. Whereas in the demand side, you have not only companies, but individuals, government agencies that may face a lot of those low-hanging fruits. So you want to ask, what's the electric fence? Couple of the barriers, and I'll try to go over these very quickly. With utilities, well, the typical rates, and I'm talking with a Texas audience, and Texas has been very innovative in the energy area. We were too in California, but it cost us something. You've been innovative in very positive ways, but the typical rates, utilities have a variable cost plus a fixed cost recovery, so that if you sell more than you expect, you get an extra profit. You sell less than you expect, you get less profit. Therefore, there's an incentive to sell more, not less. So when you talk with the utility typically about an energy efficiency program where they sell less, it's less than most, it's less than excitement usually. Second, we generally don't have time-dependent pricing. We generally have time-independent pricing in typical electricity rates. That means there are times where electricity is more expensive than others at the wholesale level, but it doesn't translate through to the retail level. So this creates wrong incentives. So the pricing system is not really conducive towards energy efficiency. But there's a lot of behavioral issues. The energy efficiency gap is often studied where it looks like for individuals there's a lot of things that look economically attractive they don't do, and the question is why. Very poor, several issues. Poor information about electricity prices and uses. Most people, for example, who have cable television have a set-top box that does recording. What you may not know is, if yours is like mine, when it's on, it draws 38 watts. then you turn it off, the lights go off, and it draws 38 watts, exactly the same amount. Most people don't know that. You can unplug it, but then it takes a long time to get the information up. That has to do with the manufacturer's decision of what you're being offered. I was tried to buy a television at my favorite toy store, Fry's Electronics, and went to, I just thought it was only sensible to understand the electricity use, so I unplugged it, put a watt meter in there, and a salesperson came looking terrorized. Why have I unplugged it? What is this thing I put in the middle? And I explained, what it was, and he said, no, it could damage things. How could it damage it? I bought this on the other side of your store. Well, he wouldn't let me do it, so I walked away. 5 minutes later, I came back. He wasn't there, so I could do the test. Nobody's that silly as I am. It just doesn't happen. So people have very poor information. Mostly low salience. Frankly, it's a low fraction of most people's income. They make gripe about it, but it's in the U.S. it's about 2%. Electricity and all energy in the household is about 2% of disposable personal income. High capital costs. There's also market failures. I mentioned about the set-top box. If you look at the difference between owner-occupied versus rental homes on the implementation of energy-efficient technologies, there's about 2-to-1 difference between owner-occupied and rental, and this is a split incentive problem. That's in California. That's in the United States. On the average, it depends upon technologies, but very significant differences because of the split incentive problems. So in the limited time I have left, how to overcome the challenges. Well, I don't know if you can read this because it's so low on the bottom, but the salesman is saying it runs on his conventional gasoline-powered engine until it senses guilt, at which point it switches over to battery power. Well, that's one approach, but what it leads me into the notion is that when we're getting these behavioral issues, we need a combination of rational and irrational. From the economist's point of view, we need a subtle understanding of how people make decisions. So at the rational level on electric utilities, we could have decoupling of rates. You can have a regulatory policy that decouples net revenues from sales. If you have an energy efficiency program, you don't recover the full capital costs, then you have a true-up at the end of the year and you adjust rates next year. It's actually a pretty easy thing to implement. So for a regulated utility, which you do have in Austin, you regulate yourself, and parts of Texas you do, it's parts you don't, and most of the rest of the United States you have regulated, price regulated. So the Utilities Commission can set a pricing structure which will eliminate that negative incentive for utilities. You can even go further by allowing earnings on successful energy efficiency programs done in combination with the customers. In California, we've done this for a while, and it's amazing how much electric utilities got religion about energy efficiency once they could make more profits by doing that than selling electricity. We need the time-independent pricing and typical retail rates. Okay, I'll end quickly. Is an issue. I think we need to go at least to critical peak pricing, but we got to realize that the more we have time dependency, the more we have risk bearing on the consumers, and those are trade-offs we have to pay attention to. There's behavioral barriers we can take into account with labeling and information systems, feedback through smart grids, but I just suggest that the way that utilities are displaying the information is absolutely useless for motivating behavior, as we have found out in empirical tests on the ground. And social norms through like O-Power and the billing of materials, new business models, stochastic rewards, and because the moderator is looking at me knowing that I should end, I shall, but leave you with this point is that in order to get energy efficiency, we got to go beyond just technologies. We really have to understand the human behavior, both in the economic incentives and the social incentives, and start working with them as part of the system. Thank you.
Okay, thank you very much. I don't think I want to leave plenty of time for questions from the audience, so I'm going to ask, instead of an individual question to each panelist, I'm going to try to group this a little bit. So let me ask Franck and Cyril a question about nuclear power in Europe. You both made reference to plans for a geological repository, is that correct? In Europe, that issue, as Cyril referenced, has been a really difficult political issue here in the United States. And we'd like to hear, I think, at least I'd be curious to hear if it's been as politically difficult in Europe as it has been here. And what's the prognosis for a repository there?
Maybe, shall I start? Or do you want to? It's been, at least in France, it's been a long-term issue. And what I can say is that we first had some legislation in this field in 1991, and that was meant to go on with research in this field of waste. When research was done, there was a new legislation, 2006, building on the results reached through research. And this legislation is now being implemented, and we are going to start, I think, under the control of Franck, I think in early 2013, we're going to start the final public debate to finalize a decision on a geological repository for high-level, long-lived waste in France. 2 or 3 comments on this. This was made possible because of the involvement of a number of congressmen in France who've been carrying this issue since 1991, actually. The ones involved in 1991 are still involved today. And it was a bipartisan approach. That's very important for the result we got today, I think. Second thing is there was a strong involvement of the public in all these discussions. You cannot force a waste repository to the public if they don't want it. So you need to get the involvement of the local responsibles and locally of the public. And I think the last thing is we have a provision in our legislation in France in this field of waste that forbids to dispose of non-French waste in France for long term. And so that's also one key to our success in this field till now, is that we were able to convince the people that France was not going to become the disposal for waste coming from all over Europe or even from some other parts of the world. As far now as Europe is concerned, it's more difficult to say. There is no real European policy in this field, though there is a directive in the field of waste, but it's more in terms of general goals than in terms of implemented solutions.
Just a few more words on the same subject. I would like to underline really the role of the Congress. Cyril did it, but it is of interest that we had, in fact, an initiative to create a geological repository for high-level waste disposal in the 80s that failed because of public opposition. And then this was the origin, I would say, for the Congress really to promulgate, the Act of 1991 to set up a 15 years framework of research to do research along different lines, let's say recycling in reactors or interim storage or geological repository. And as Cyril said, so the continuation of that is the Act that has been promulgated in June 2006 that really aims at concretely implementing the geological repository. So as he said, public debate is, in preparation for 2013. The authorization decree for creating the facility is expected in 2015 after the bill, and then this geological repository will enter into operation in 2025. And then, so this is the situation, so we cross fingers and we'll see.
For what regards nuclear energy in Europe, let's say there are mixed feelings. I think out of the 27 European countries, some like 15 are nuclear. It is of interest to see that, well, some really decided to phase out of nuclear, so Germany, Italy, Sweden, or Belgium, but some others, like the UK, are really betting on nuclear and are betting on a balanced mix of carbon-free energy sources. So to really make renewables comply with nuclear. And Eastern European countries have a long history of nuclear operation, well, in cooperation with the former Soviet Union, which somewhat balance, I would say, the negative sentiments that are more in the west of Europe. And this is of interest that, in fact, the variety of energy policy in Europe could be an asset if ever, let's say, the global energy mix was to be optimized. But the current situation is that, well, competition is more, let's say, well, energy policies are really being decided and implemented at the national level, and competition is really organized between nations.
So just to be clear, in France, has a site been selected?
Yes, in fact, the bill of 1991 was making provisions for two sites to be prospected as laboratories. And in fact, it turned out, and two sites were selected in the early 90s. One was made of clay, the other one of granite. In the mid-90s, it turned out that the granite site turned out to be too much fractured to be, let's say, eligible for a repository. And then a search for a second repository was launched, which failed because of public opposition. So now, well, the laboratory, the prospection for the suitability of the geological, let's say, site only applies to the clay site, which is in northeastern France. So we only have one site.
Thank you.
Where there is already a lab operating, so it should be easier.
So similar to the way we put our new facilities next to the old facilities, sort of same theory there, yeah. Speaking of which, I wanted to ask Finis a question, because you spoke broadly about the trajectory of nuclear power in the United States, and we heard reference to the new plants being built in Georgia and South Carolina, and those plants are being built in states that have traditional regulation and in states that have given all sorts of financial incentives to make the investors feel more secure about earning a return on their investment. And I'm putting you on the spot because I didn't tell you I was going to ask you this question beforehand, but I wonder what you think about the sort of broader future of, just if you could just briefly say something about the future of nuclear power in the United States outside of a context in which those extra incentives are offered.
Yeah, a couple of things there. You know, we have actually 6 nuclear units under construction in the U.S. right now, which is quite an advance, if you will. Watts Bar 2, which was an old non-completed plant, is under construction to be completed in a few years. And Bellefonte is another TVA plant that's being restarted its construction, which was originally abandoned in about 1987. So both of those are felt to add some capacity, but they're clearly Gen 2 plants, so it's sort of an interesting exercise, I think. The other 4 units are Vogel 3 and 4 and Summer 2 and 3, which are the first Gen 3 plants, if you will, to be built in the U.S. And everybody's, I follow Cyril's hope there, is if they are on time and on budget roughly, that will be good. If they're significantly over schedule and over budget, then that will be a terrible signal for the market, given their favorable location. South Carolina and Georgia are about as beneficial as you can get in terms of a favorable regulatory structure. Next in line would be, of course, you know, states like Florida and Alabama or other southeastern states, states where there's clearly a growth, a growing electricity need compared to the northeastern states. So if those succeed well, I think the prospects are good going forward, and as you can replicate. The big challenge, of course, under the new regulatory regime is that any new plant seems to take about 12 years to license now, and in 5 years at least to build. So you're saying from the time you start the process and you have a design you think will be favorable to the market, it'll be 17 years before you can see it come to pass. this new regulatory, quote, regime was developed, Part 52, to reduce risk. But it has, in many ways, new risks have been found by such a long regulatory process, and maybe experience will decrease that for the NRC. We can do better than 12 years. But if we don't, you won't see enough new plants coming along to do it. If you take an SMR, for example, and it takes 12 years to license, and then even if it's 3 years to build, you've just reduced from 17 to 15, and that won't be adequate to make investors feel comfortable. So we've got to get through the regulatory process more quickly in the future, and these ongoing 4 plants have to do very well. And then I think we'll see a resurgence in this decade.
Okay, thanks very much.
Yep.
Jean-Baptiste and Jim, you both spoke a little bit about smart meters and sort of demand-side options, I guess. And we often hear about, once we have smart meters fully rolled out and we get sort of time-dependent pricing, some sort of dynamic or real-time pricing, we ought to be able to offer incentives that get people to shift demand, along with the behavioral ideas that Jim talked about. But we also see, at least you both referenced Northern California. You referenced it, JB, and Jim's from Northern California. We see opposition to smart meters there in some places. I don't know if you see this in France based on security or privacy issues or health issues. Can you speak, can either of you sort of give your prognostication about how you see the future of, or when you see time-dependent pricing working the kinds of effects that we hope it will work and shifting demand, shaving peaks and that sort of thing? Can you just give a brief sense of how you...
Yes, very briefly. Smart meters were developed by our regulated subsidiary, ERDF, the network owner of medium and low voltage in France. And I'm the opinion of the fact that they launched it too quickly. So the people at this time, they were aware of energy efficiency, but not enough educated to welcome this product in their house and to counterbalance the kind of situation where all of a sudden the power is cut. So I think it will take probably 5 years in order for the people to be accustomed to this new way of energy management. Now, I'm not sure about the companies, and especially the electro-intensive companies, but I think it goes in any way in the right direction, because we definitely need to have a better assessment on, especially to manage the peak. But I think it's a good way. The only thing is that it's just going to take years until it is really spread and accepted by the public.
Couple of comments. First, on the opposition to smart meters. I believe that there was a lot less than met the eye. We had people and communities going up and protesting violently that they had the smart meters because of the radiation. I view them holding a telephone to their ear by saying, "There's radiation from these smart meters. You can't let this happen." Well, the press picked it up, and it looked like it was a big deal. And then the Public Utilities Commission said, everybody can opt out. You just have to pay the extra metering cost. It's a very small amount of money. It could cost you a couple $100 total to opt out. And a very small number of people ever opted out, and the opposition and the noise sort of died down because people have if you complain a lot, you can say no, and for most people it wasn't worth very much to not have them. So less opposition than appeared. But I think the important thing is that we need to have new ways of communicating the information back that becomes useful and motivational. If you look at the way the information is coming back, it's through the utilities. It's a plot of the rate at which you're using electricity on a real-time basis, usually an hourly basis, but it could be a smaller time basis. And you see peaks and up and down there. First, you focus on what's the message you get. Well, the message is, how do I fix the peaks? The reason your electricity bill is high is because of the base, what you're going through all the time, not this narrow peak. So you've got the information that's brought back and sort of misdirects you. But more importantly, we did an experiment on the ground using a group of Google employees, control group, experimental group, all of the standard experimental design. And what we found out is that having smart meters, which people got information right away, did allow people to reduce their use of electricity by about 5% in the first month. But by the end of 3 months, there was no statistical difference between the control group and then we let the control group have access to the meters for the first time and all the information. And they were 5% below the experimental group for the first month until within 3 months there was no difference. There's zero persistence in response for the type of things that we have. So we need to figure out how to get the information back so there really is persistence. And I envision things like a bit of communication that sometimes just talks to you and says, hey, your refrigerator is using a lot more electricity than usual. Clean the coils, you turkey. Or it says, we see that how much particular appliances they're using. Here's the price of a new one. You can pay for it in 4 years if you wanted to buy a new one. That's usable information. What's happening now is we're not getting usable information actionable. Until we get the actionable information, I don't think we're going to get anything of real value for consumer use of smart meters.
Thanks very much. We have about 5 minutes for questions from the audience. Sir in the back. Yeah.
How much does recycling your nuclear waste reduce the amount compared to U.S. nuclear waste? My understanding that France is trying to eliminate nuclear waste almost altogether.
I've been asked to repeat the questions because they're not coming over the camera, over the audio for the camera. So the question is, how much do you reduce the volume of waste through nuclear waste through recycling? Right. Who wants to take that one? Yeah.
Well, currently France is recycling, let's say, reprocessing the spent fuel, and it's recycling once, let's say, the plutonium. And so this leads to, let's say, having spent MOX fuel. The technology that really achieves significant, let's say, benefit in recycling is really fast neutron reactors. I mean, this is the next generation. So the same physics that achieves an efficient use of natural uranium, so 80, 90% in place of 0.5% of light water reactors, also has the capability to burn, to fission the, let's say, transuranics. And then this would reduce by 2 orders of magnitude, let's say, the amount of waste as well as the, let's say, radiotoxicity of the waste. So let's say shortening the period when the overall radiotoxicity of the ultimate waste reaches that of natural uranium, from which, let's say, the fuel was manufactured initially, let's say, to about 300 years, which we think is gives an assurance of having, let's say, the confinement under good control.
So we're gonna. Unfortunately, we don't have much time left. So I think we'll have the panel be able to be approached afterwards. We only have time for a few more questions. Yes, Letitia. The question is, how will the reduction of the rebalancing of the French energy mix that includes a reduction of nuclear reliance on nuclear from 80% down to 50% affect energy security in France? Who wants to take that?
I start and then, or maybe you can go.
Well, I think the answer to this question depends on what the backup power of renewable energies will be. So if you use gas, which has the appropriate dynamics, and and we will do that, I would say, at the minimum because of the price of gas in Europe until we exploit the shale gas and then we decrease the price. So then I would say, well, the impact of let's say, this transition in energy would really, well, depend on the import of gas to really achieve this goal.
Yes, sir.
So it was touched on a little bit, perhaps, or alluded to. What about using electric vehicles to displace oil to reduce overall emissions and also buffer the intermittency of renewables? Touch on that, how much that may or may not be a focus in France. And I haven't heard one word about Fukushima. How did that affect the French?
Snuck in two questions, but that's okay. One is on electric vehicles and how can they be used as part of the system, perhaps for storage and so forth. The other was about the effect of Fukushima on the future of nuclear in France. Who wants to take that?
Well, I can deal with the electric vehicles. I think, no, it's going to happen around the world, so it doesn't much matter. We're going to be moving towards electric vehicles, I think, over the long run. However, one has to realize it's not going to be a quick process. In the U.S., hybrid electric vehicles were introduced about 14 years ago, and we're up to now 3% market share already. And that didn't take any behavioral changes to get there. So I think once we get batteries a lot cheaper, and we then start developing electric nuclear infrastructure, we're going to have a lot of electric vehicles, and it's going to happen around the world. It's going to happen in France and the United States, because the marginal cost of electricity for running them is a lot lower than oil than it's going to be.
How does EDF think about cars?
Yeah, well, we have a JV with Toyota in France where we try to work together on a new hybrid vehicles. The only drawback is that it's a question of storage. We're still working on a way to optimize the length and the capacity of the vehicle for long term. For a long journey. The only thing that matters today is to make sure that we have the network to allow the electric vehicle to charge their battery on the public way, or in the companies, in the parking, and that needs to invest a lot. But that's a very interesting question because you can't push electric vehicle if there is no infrastructure to support this improvement. But what is very interesting is that you can reload electric vehicle during off-peak time. So it's a way to manage energy in a better way. So we cross our fingers and try to think ahead. Concerning Fukushima, maybe my two colleagues will be...
One word on Fukushima, maybe, and both of you can complement. After Fukushima, it was decided at the European level that stress tests should be carried on. So this has been done. There have been some results made public, and in addition to the stress tests carried on with all the European fleet, there were stress tests carried on by the French Nuclear Safety Authority on all the French fleet. And the conclusion of those tests were that known plant needed to be closed based on the first lessons learned from Fukushima. And I just say based on the first lessons, because Fukushima will need time before we can really have all the lessons learned from Fukushima. It might take 10 years. I mean, you don't get into the reactor at Fukushima yet, so we will need time to learn all lessons. But from first lessons learned, it was decided that no plant needed to be closed, shut down, though some improvements should be made. And of course, this is going to have a cost. So, but then I will maybe turn to my colleague at EDF because they will carry on with those costs, I guess.
Yeah, sure. Definitely.
Briefly,
now,
please.
the question I wanted just to raise, it's a more global question concerning the regulatory role and the regulatory authority. I think it's of the essence that we have a strong regulatory authority. And Fukushima is a lot about a weak regulatory authority. And that situation cannot go along with nuclear. It's of the essence. Otherwise, we could stop this technology if we don't have a strong regulator who controls, who knows our power plants.
Let me apologize to audience and panelists alike for having to cut off questions and follow-up questions. We are running into a time constraint and we need to move on. But the reason we have so many questions is because we've had such an expert and esteemed panel here today. So please join me in thanking them for sharing their thoughts with us.